Hey everybody, this is Mr. Hartzler, and I'm going to talk to you in this video about finding centroids. This is from my Project Lead the Way's Principles of Engineering. On this page here you see all the formulas for the general shapes. We have squares, and x bar, you essentially are finding the average of our base. So in this case it's a 2. I divide that number by 2, simplifies to get you a 1. You do the same thing for your y if it's a square, or a rectangle. The average of your height, so it's your height divided by 2, and in this case again it equals 1 because this was a perfect square. So our centroid, it is that little symbol right there, is right in the middle. Triangles, very similar. Let me zoom in a little bit here. So for triangles, it is our base divided by 3, and for our y coordinate to it, it's height divided by 3. And my base is 3, that divided by 3 gets you a 1. My height is only 2, divide that by 3 and you'll have to 0.666 repeating or just rounding off to the 7 there. So our little coordinate point here for our centroid is right there. We're over 1 and up 2/3. To the right 1, up 2/3. That's how I would classify that. I would write it more as a coordinate point. For semicircles or semicircles, that formula is a little bit more complicated. The base is easy. It's half the base, so it's our base divided by 2, and in this case it's going to be a 5 because we're 10 centimeters wide. For our y, we have 4 times the radius divided by 3 times pi, and in this case we have a radius of 5, so we end up with 2.123 for our y component to our centroid. Alright, that's general shapes. Pretty basic ones here. And those are also, if you're one of my students, those are on the PowerPoints that are available to you on Google Classroom. Now we're going to do a more complicated shape. That's this one right here. And we're going to start off by looking at all of the little pieces. And I'm going to tell you I do the whole thing, in this case as a subtractive method. So I'm going to treat it like it's one solid rectangle. That's going to be our shape 1. Then I go into my little rectangle, this chunk here, as chunk 2, and I'm going to subtract that one away. Then I do my semicircle, that's going to be part 3, and I'm going to subtract that one away also. So the overall piece is going to have a positive area, but because these two are actually negative space, it's going to be a negative area. Alright, so here's that page if you want to screenshot that or something so you can get all the dimensions down. So we're going to go on and look at each piece. Again, I'm going to look at one first. It's my overall shape. My overall shape is 8 wide, and I am 10 tall. And I'm going to use this paper here to do kind of a nice, neat little description of all of it. So my x coordinate, or how this overall piece, remember we find squares by doing, or rectangles by doing half the base, so 8 divided by 2. 8 divided by 2 gets me 4. What's the area of my overall square? That's going to be 8 times 10, so that's 80. Then I multiply these two components to get xi times ai, and that gets me 320. Bump the mic there. Next thing I need to do is look at part 2. Part 2 is the half box thing up at the top, this little area that's cut out. If I look at my dimensions, you can see the overall is 8 and each piece here is 2, so this width is going to be 4 and my height is noted over here as 2. So if I am 4 wide, I need to bring that paper back here, my x component for this is still going to be all the way over in the middle. And if I'm 8 wide overall, I need to be 4 over. So the x component for this is still going to be 4. It's still my overall width divided by 2. Then the area, that's the one I talked about for you a second ago. This is 4 by 2. I have an area of 8. multiply those two things together, I have 32. But wait on this one. That is negative space, isn't it? It's not part of my actual shape. So that's a negative area. My last shape, shape 3, how far over am I on my x-axis? I'm over in the middle, because I want the middle of the little the circle here. Right in the middle is going to be 4 over. And what's the area of a semicircle? Well, that's pi r squared. My radius is 2, noted right there. And 2 squared times pi gets you 12.56. But again, negative space, so it's a negative area. I multiply xi and ai, and that gets me my negative, oops, sorry, that one's negative there too, because of the negative area. It's a negative 50.24. Now for our overall formula, we're going to have to add these down for our areas, and we get 59.44. We had a positive 80, negative 8, and negative 12.56. Then we had a positive 300, minus 32, minus 50.24, and with a positive 237.76. We're going to do the same thing now for our y components. This one can sometimes be a little tricky. My overall square still isn't going to be bad. I'm in the middle of my square, and I'm 10 tall. I only go up 5. The area is going to be the same as this top chunk, so I can actually label all of those right now. That's going to be an 80, negative 8, a negative 12.56. The areas don't change. And the y component now for my small rectangle is half this little height here. And if that's 2, that means this centroid is going to be 1 down, but I'm considering this bottom left corner to be my origin. That's how I've organized all of this. So how far up is that? And that is 7. Oh, sorry. If it's 10, this is going to be 9. I'm 9 up from that origin point. So my height on that one is going to be a 9. That's the tricky part. You might find it for just this little piece and say, oh, well, it's only 1 up from here or down from there. But really, we have to consider the overall shape in that case. And then our coordinate 3, or this is for our semicircle. And that formula is a little bit unique. If we look back at that first page I had up, semicircles, it's 4 times the radius divided by 3 times pi. That's 4 times the radius divided by 3 times pi. So 4 times 2 divided by 3 times pi. And that gets you a nice 0.849. Multiply all of these numbers across to get my yi times ai. Top number is not 30 anymore. We are now at 400. 9 times negative 8 gets me negative 72. And 0.849 times negative 12.56 is a negative 10.663. We add down again for our totals. This one's the same as last time. And we have 317.337. Now we have to look at our overall formulas. Our overall formulas have some funky symbols involved. We have x bar equals the summation of x bars times areas over the summation of our areas. So when we look at this, we're going to pull the numbers from the last sheet we had, from this neat little table. This number here, this 59, that is the sum of our areas. This one is the sum of xi's times ai's. Down here we still have sum of our areas and sum of our yi times ai. So that's where we're pulling all of these numbers from. So in this case I'm going to substitute in this top number comes from this far right box under our totals, this one right here. So that's a 237.76. Dividing it by my area, that is 59.44. We bring out our calculator. 237.76 divided by 59.44. Nice, cool 4. Then we'll come down and we'll talk about y bar. Very similar. Sum of our y bars times our areas divided by the sum of our areas. Again, I'm pulling these numbers from this table here. These bottom two numbers, those totals. So we have 317.337 divided by 59.44. And we end up with 5.339 if we round up. So what that's saying is on our overall picture here, I have centroids of my overall piece, and the overall square was smack dab in the center. To the right 5, up 5. This one was to the right, oh, not 5, this is, should be a 4 here, sorry about that. That should be over 4 and up 9 for that centroid. And this one, if I look at that nice little table again, that's part 3. So I was over 4, up 0.849. 4.849. Then I have my final answer of 4 and 5.39. Zoom out a little bit here. That came from this paper here, my overall x bar and y bar. And that is at 4 and 0.533, so I'm over it a little bit. Right here, just a little above. That should be my overall piece. And that just has to do with this cutout being a little bit less than this. So I had to lean a little bit more towards that top side to make it balanced. So that's the overall piece. I would also label that I'm over 4 and up 5.339. The important thing to note too, everything was centered, and our axis of symmetry is always where our important things are going to lie. So if I draw on here my axis of symmetry, all of the little centroids for each individual piece lie on that line. If you have a line of symmetry, then your centroid is going to be lying on that line of symmetry. I hope that was helpful. If you're one of my students, hopefully you watch this and can learn something from it. If you're not, please leave a comment below and let me know if this was helpful or not, and I can make edits to future videos. And if you have any questions about other engineering things related to principles of engineering or anything else, please leave a comment below and I can hopefully make a video on that. My Instagram is Mr. Hartzler and my Twitter is Mr. Hartzler Math. Please like this channel, or like this video, and subscribe to the channel, please. Have a great rest of your day, everybody.